Hi everyone, it's Coach Fred here, and I'm really sorry about class today. I was going to be going over some of the questions you had from your video. I asked you to do numbers 1 through 6 in the packet, and you guys asked me to go over actually 3 and 5. So I'm going to go over number 3. Yeah, I can see why this one might have given you some trouble. You have to notice that there's parentheses, and there's parentheses on both sides of that inequality symbol. And I have to be especially careful when there's a negative in front of parentheses. A negative in front of parentheses means you have to distribute it through, but it means make everything inside the opposite. So if I do that, it would give me 2k minus 7. If I make everything inside the opposite, it becomes negative 3k and negative 5. If you made a mistake, you might have forgotten to bring that negative all the way to the 5. All right, so then is greater than or equal to, I want to distribute my 5 through the parentheses, so 5k minus 15. All right, then you want to combine like terms on each side. So we have a 2k and a negative 3k, which gives me negative k, and I have a negative 7 and a negative 5, which gives me negative 12. All right, is greater than or equal to 5k minus 15. Now here's the big thing. Remember we talked about you always want the variable on the left. So you actually should subtract 5k to the other side. And then you're going to add 12. Okay, so that's going to give me negative 6k is greater than or equal to negative 15 plus 12 gives me negative 3. All right, now here's where it gets tricky. We have to isolate the k, so we are going to divide both sides by a negative 6. When we divide an inequality by a negative, we have to flip the direction of the sign. So that would give me k is less than or equal to 1/2, which was how we got that answer. All right, so then number 5. Number 5, you might have made a mistake if you just combined like terms and you left m on the right side. So first, you always want to combine like terms. There's no parentheses, so I don't have to worry about that. So that's going to give me m minus 10. Now what happens is a lot of kids are just going to add the 10, which is fine to do, except inequalities we want to read from left to right, and we want to read with the variable. So one thing I always do when I'm looking at the inequality, I kind of pretend it's like an arrow. So you can see it's pointing to the 5. I need to flip this around so the m is on the left, but I need to verify that those inequality symbol is still pointing at the 5. You see what I mean by pointing at the 5? So m is greater than or equal to 5. All right. What I was planning on going over in class today was moving on to number 7. So I would like you to go ahead and try number 7, press pause, and then I'm going to do it. Okay, so you pressed pause, you're back. I distributed my negative 3 through, so that gave me negative 12 plus 3m is greater than or equal to, I'm going to distribute my 4, which gives me 8m plus 4. Be careful that you distribute all the way through. Make sure you distribute that negative all the way through as well. All right, I'm going to isolate the m, going to get it on the left side, so I'm going to subtract the 8m. And then I'm going to add the 12. I'm going to do that all in one step. All right, that gives me negative 5m is greater than or equal to 16. I got to isolate the m, so I'm going to divide. It's being multiplied, so I do its opposite. So I'm going to divide by negative 5. But yep, I'm dividing by a negative. I got to remember to flip the inequality symbol around. Remember, negatives do the opposite, so we need to do the opposite direction when we're doing inequalities. All right, I do want to talk about fractions for a little bit. There's several ways to do this, but what I want you to notice is that I have one term on the left and a fraction on the right. So there's 2 ways that you can do it. I'm going to do it both ways, okay? One way is just to go ahead and clear fractions. That's going to take one additional step. If you're comfortable with clearing fractions, that might be the way to go. So you'd multiply both sides by 6, both sides of the inequality by 6, and you'd get negative 18x is greater than or equal to 5. That's totally fine to do. And then divide by negative 18. So when you divide by a negative, you're going to flip the direction of the inequality symbol. So negative 5 over 18. That's one way. Another way to do this is because it's just 2 terms, one on each side, is to multiply by the reciprocal. Well, why do you say that? Well, because if you think about it, we're trying to isolate x. So if I want to get rid of that -3, and I multiply by -1/3, which is the reciprocal, what happens is the 3's will cancel, the negatives will cancel, and I'll be left with 1x. I'll get right there. And then all I have to do is multiply 5/6 times -1/3, which gives me -5/18. So either way, that works. All right, I want you to pick one, and I want you to try number 2. Press pause, try it, and come back. Okay, so you'd be multiplying by both sides. I'm going to clear fractions on this one for you. So I'm going to multiply both sides by 7, which gives me -28y is greater than or equal to -3. I'm going to divide by -28, and that's going to be y's less than or equal to 3/28. Okay? Now again, you could have multiplied by the reciprocal. And why is that? Why are we multiplying by the reciprocal? Because what you guys tend to do is divide by -4. But when we divide by fractions, remember, dividing fractions is the same as multiplying by the reciprocal. So that's why I'm saying you can multiply both sides by the reciprocal. So we could have multiplied both sides by -1/4 to get rid of the -4. And then that again would clear it to a single y on the left, and then a negative times a negative would have become positive, and it would have given me 3/28. So either way is fine. All right, I want you to try number 3 and 4, and press pause, and we'll just check them. Okay, so you tried these. I'm not going to go through them, but if you need to pause, you can. You should have gotten y is greater than 3, and you should have gotten x is less than 4. All right, I do want to look at question number 7. I want you to notice that this isn't one term on one side and one term on the other, so you can't multiply by the reciprocal here. You have to clear fractions here. So first, find the lowest common denominator, just like we would if this were an equation, and we're going to multiply that lowest common denominator to every single term. So 15 is the lowest common denominator. All right, then we simplify. 3 goes into 15 5 times. 5 times 2 gives me 10. 5 goes into 15 3 times. 3 times -x gives me -3x. Is less than. 15 and itself, they cancel to 1, and we're left with 4. Now we solve. So we subtract 10 to both sides, and we get -3x is less than -6. There we have to divide by that negative, so can't forget that we are flipping the sign. All right, we're gonna, the one thing I wanna stop on today is I wanted to just kind of get you thinking about some geometry terms that we're gonna be starting the year with next year. And they actually do relate to inequalities, okay? I'm gonna go back for a second, and if I took this x is greater than 2, if I drew that on a number line, which we did the other day, I'd put the number 2, and I'd have an open circle going like this. And that actually has a name, but it has all these different parts. So let's talk about those parts. A point. A point is just a place or a location. But everything that we deal with, every shape, every instance in the world, everything has points. Like you live at a certain point, I live at a certain point, but so we have to be able to describe points. We have coordinate points. Coordinate points we often describe using an ordered pair. But if it's just points on a number line, we might give it a number as well as a letter. All right, let's talk about a segment. A segment is a piece of a line. A piece of a line. A segment looks like this. It actually connects 2 points, and it has distinct endpoints. We'll say A and B, okay? An array. Array is what I just drew. Array has a point, or it starts at a point and goes in one direction forever. Now, I had an open circle. It's still array. It just doesn't include that point. But normally when you draw arrays in figures, they're going to be closed points. Array could go like this. It could go like this. And then we have a line. A line goes on infinitely in both directions. And when we use lines to graph inequalities, we usually draw it like this over the, over the number line. And that would mean all real numbers. Okay, so everything that we're going to be doing with the next set of inequalities called compound inequalities is going to relate to these 4 geometry terms. So I wanted us to just see what they were and make sure you understood what a point, a segment, a ray, and a line were. All right, guys, have a great day.